Hello, my dear students. Welcome to Teacher at Home. Today class we are going to learn the sixth chapter, Eyes in the Sky and Analysis of Information. You understood how the surface features of an Earth are depicted on maps and analyzed. The advancement in the field of science and technology have made information gathering, map making, and subsequent analysis easier and more efficient. Through this lesson, you can understand how the launching of satellites and the use of computer software for the analysis of geospatial data make learning geography more human-centered. Remote sensing. The invention of photography in the 19th century has brought about a drastic change in data collection. The possibility of capturing photographs from higher elevations, mounting cameras on balloons, and aircraft had been explored ever since. Data collection using satellites began in 1960. Along with cameras, different types of scanners were also introduced for data collection. Such a method of collecting information about an object, place, or phenomenon without actual physical contact is remote sensing. An energy source is essential for remote sensing. This may be the solar energy containing electromagnetic radiation or an artificial source of light. Remote sensing is made possible either by utilizing the sunlight or an artificial light reflected from various objects. When photographs are taken by using a camera with flash, camera is the sensor and the light being from the flash is an artificial energy. Artificial light reflected from various objects. When photographs are taken by using a camera with flash, the camera is the sensor and the light beam from the flash is an artificial energy. Electromagnetic energy reflected and radiated by objects is utilized in remote sensing technology. Devices used for data collection in remote sensing are called sensors. Sensors. Cameras and scanners are sensors. The sensors record the electromagnetic radiation reflected by objects. The carrier on which the sensor are fixed, it is called a platform. So the carrier on which it is fixed, it is known as the platform. Sensors can be installed on balloons, aircrafts, or satellites. Based on the source of energy and the platform, remote sensing can be classified as follows. Classification of remote sensing based on source of energy. Remote sensing. Passive remote sensing. Remote sensing is carried out with the help of solar energy. It is known as passive remote sensing. Here the sensors do not emit energy by itself. Active remote sensing. Remote sensing made with aid of artificial source of energy radiating from the sensor. It is known as active remote sensing. Terrestrial photography. The method of obtaining the Earth's topography using cameras from the ground is known as terrestrial photography. Also, method of obtaining the Earth's topography using the cameras is known as the terrestrial photography. Aerial remote sensing. The method of obtaining photograph of the Earth's surface continuously from the sky by using cameras mounted on aircraft. It is known as aerial remote sensing. And satellite remote sensing, the process of gathering information using the sensors installed in artificial satellite is known as satellite remote sensing. You understood the different methods of remote sensing. Aerial remote sensing. Aerial remote sensing is generally used to gather information about comparatively smaller areas. Advantage of aerial remote sensing is that information of any region can be gathered in accordance with our requirements. Another merit of this method is that contiguous picture of the areas along the path of the aircrafts are made available. Photographs obtained through this method are called aerial photograph. In each aerial photograph, nearly 60% of the places depicted in the adjacent photo is included. This is done by ensuring contiguity and to obtain three-dimensional vision with the help of stereoscope. It is called overlap in aerial photographs, illustrating the concept of overlap. It can be seen that each photograph exhibits as much as 60% area as repetition. Major share of these areas in the picture A and present in picture B and those of the figure B are repeated in figure C. Two such photographs of adjoining areas will overlap and is known as the stereo pair. Figure A and B as well as B and C are stereo pairs respectively. The instrument which is used to obtain three-dimensional view From the stereo pairs, it is called stereoscope. When viewed through a stereoscope, we get a three-dimensional view of the depicted in the view of the area depicted in the stereo pair. Such a three-dimensional view obtained it is called stereoscopic vision. The aerial remote sensing has several advantages. They have some limitations as well. Let's see what they are. The shaking of aircraft affect the quality of photos. Aircraft require open space to take off and launching and landing. It is not practical to take photograph of regions that are vast and extensive. Landing the aircraft frequently for refueling increases the cost. With the advent of remote sensing, using artificial satellites, these limitations have been overcome to a great extent. Now let us understand the method of remote sensing by using artificial satellites. As aerial photographs are highly useful for viewing a region as a whole and for distinguishing the heights and depressions of the Earth's surface, aerial photographs were used widely since the Second World War. Aerial photographs are also used for the preparation of topographical maps. Aerial photography started in India after independence. The responsibility of aerial survey in India had been vested with the Indian Air Force, Indian Aerospace Company based in Kolkata, and the National Remote Sensing Center. Satellite remote sensing. The process of collecting information using sensors fixed on artificial satellite. It is called satellite remote sensing. These artificial satellites are mainly divided into two types, geostationary satellites and sun-synchronous satellites. Geostationary satellites. These are the satellites that move in equal velocity with the Earth's rotation. Features of these satellites are given below. They orbit the Earth at an elevation of about 36,000 kilometers above the Earth. One-third of the Earth comes under its field of view. As the movement of the satellite corresponds to the speed of rotation of the Earth, it stays constantly above a specific place on the Earth. This helps in continuous data collection of an area. It is used in telecommunication and for weather studies. India's INSAT satellites are examples of geostationary satellites. Sun-synchronous satellites are the artificial satellites that passes around the Earth along the poles. Features of these satellites are given below. Orbit of the satellite, it is about 900 km in altitude. The surveillance area is less than that of geostationary satellites. The repetitive collection of information of a region at regular interval is possible. Used for the collection of data on natural resources, land use, groundwater, etc. The satellites are mainly used for remote sensing purposes. Satellites in IRS, Landsat series are examples of sun-synchronous satellites. Haven't you understand that the information about the Earth's surface is collected with the help of sensors? Sensors record the electromagnetic radiation, either reflected or emitted by the objects. Each object on the surface of the Earth reflects electromagnetic radiation in different measures. For example, the energy reflection of plants is different from that of water bodies. Amount of reflected energy by each object is called the spectral signature of that object. Like the amount of energy, reflected energy by each object. Sensors on artificial satellite distinguish objects on the Earth's surface based on the spectral signature and transmit the information in digital format to the terrestrial stations. This is interpreted with the help of computers and converted into picture formats. These are called satellite imaginaries. The size of the smallest object on the Earth's surface that a satellite sensor can distinguish is called the spatial resolution of the sensor. Look at the figures. These are the satellite imageries captured by two sensors with a different spatial resolution. Can we see the feature of the Earth's surface with a greater clarity? Sensors took images with the help of spatial resolution. Name of some satellites and their spatial resolution are given below. Satellite. Landsat 1, 2, 3, 4, 5. Sensors multispectral scanner. Spatial resolution 79. Spot. Panchromatic camera 20. IRS panlist 3 5.8. GeoEye panchromatic multispectral camera 0.46. Remote sensing in India. Photo Interpretation Institute was established at Dehradun in 1966 for analyzing and studying aerial photographs. Later, this institution became Indian Institute of Remote Sensing IIRS. The satellite remote sensing in India began with the launch of the satellite Bhaskara 1st and 2nd in 1970. Institutions like National Remote Sensing Center NRSC, erstwhile NRSA, Indian Space Research Organization ISRO, Department of Space DOS, and Space Application Center SAC are constantly engaged in making use of remote sensing for the welfare of the society. The complete responsibility of collecting, storing, processing, and distributing the data made available by Indian remote sensing satellites as vested in the hands of National Remote Sensing Center, whose headquarters is at Hyderabad, NRSC. Use of remote sensing technology for the assessment of weather and its observations, for ocean explorations, to understand the land use of an area, for the monitoring of flood and drought, for identifying forest fires and deforests and to adopt controlling measures, to collect data regarding the extent of crops and spread of pest attack, for oil explorations, to locate groundwater potential places. We have understood that a large amount of information about the earth is received through remote sensing technology. We can prepare maps, tables, and graphs to find scientific answers to our queries by the analysis of the information obtained through remote sensing and other means. Using a computer-based technology called Geographic Information System. Geographic Information System GISM. Geographic Information System is a computer-based information management system by which data collected from the sources of information like maps, aerial photographs, satellite imageries, tables, surveys, etc. are incorporated into the computer using softwares which are retrieved, analyzed, and displayed in the form of maps, tables, and graphs. Entering database or basic data into a computer using data input devices like CDs, scanners is the first step. Various layers can be created based on the collected data with the help of Geographic Information System softwares. Analyzed data can be converted in accordance with our needs into products, either in the form of maps, tables, or digital data. All data analysis with the GIS are done based on two kinds of data. Spatial data. Find out the latitudinal and longitudinal location of our country with the help of website Bhuvan or with an atlas. Each feature on the surface of the earth has a location of its own. Such features on the earth's surface having a specific location is known as the spatial data. Attributes. Additional information about the characteristics of each spatial data on the earth's surface are called attributes. But attribute can be combined with spatial data. Find out the following details of your school. That is about the teachers, classroom, students, whether your school building is multi-stored or single. Details you recorded are the attributes of your school. If we can collect and include the spatial data and attribute of places in the database, this can give precise and scientific answers to the various queries about the place. Layers. Observe the portion of the topographic map shown in the figure. Haven't you seen the natural and man-made features like streams, roads, vegetation, building, etc. on the map? Can we separate the features one by one to take separate maps? This is possible through GIS. You can see that water channels, roads, etc. shown separately in the figure. The thematic maps prepared and stored in Geographic Information System for analytical purpose are called layers. Spatial relationship among the features on the surface of the earth can be understood by analyzing the appropriate layers. Topo sheet layer 1, 2, 3, shoreline drainage network. Analytical capabilities of GIS. Surface feature of a earth collected as spatial data and attribute can be analyzed in various ways by the GIS. Network analysis, buffer analysis, and overlay analysis are the important analytical capabilities of GIS. Overlay analysis. Overlay analysis is used for understanding the mutual relationship among the various features on the Earth's surface and the periodic changes undergo by them. Overlay analysis is helpful in understanding the changes in the area of crops, changes in land use, etc. For example, if we want to understand the changes in the area under paddy cultivation in Thrissur district by the year 2015 compared to 2000, all we have to do is to overlay the land use maps of Thrissur in the corresponding years. Buffer analysis. Suppose if we want to find out the number of houses located within 3 km radius of our school, the possibility of buffer analysis can be used effectively. The spatial data on the place where your school is located is subjected to buffer analysis. In GIS, a circular area with 3 km radius can be created around your school so as to find the number of houses in that area. Suppose a road in your region is widening from 5 meter to 8 meter as per the government decision. In such a situation, a zone is required width is created along the existing road by using the possibility of buffer analysis in GIS. Thus, we can easily determine how much land has to be acquired and how many people will become homeless. A circular zone created around a point feature or a parallel zone created aside a linear feature in buffer analysis is called buffer zone. Network analysis. In contrast to the other two types of analysis, the network analysis deals only with the linear features on the map. Linear features include road, railway lines, rivers, etc. The possibilities of network analysis can be used to find out the easiest and less congested roads from one place to another. The possibility of this analysis can also be used by tourists to plan the maximum number of attractive destinations in the available time. This may also help to bring an accident victim to a suitable hospital through less congested roads. Use of GIS. By using GIS, can compile data from different sources, update and incorporate data easily, conduct thematic studies, represent geographic features spatially, generate visual models of future phenomena and process based on data collected, prepare maps, tables and graphs. Satellite-based navigation system. Nowadays, satellite-based tracking systems are used for monitoring the location and movement of objects on the Earth's surface. It is used in several sectors like map mapping, making, transportation, etc. Most important among this is the Global Positioning System of the United States of America. Global Positioning System. A global positioning system helps sensing the latitudinal and longitudinal location and elevation of objects on the Earth's surface along with the corresponding time. In this system, a series of 24 satellites placed at 6 different objects orbits between the altitude 20,000 and 20,200 km above the Earth's surface locate objects. We can locate places with the help of the signals received from the satellite in our handheld device. The GPS requires signals from at least 4 satellites to display information like the latitude, longitude, elevation, time, etc. in it. More satellites are being included in the system for enhancing accuracy. Though started initially for the US defense, the satellite is now open to the public since 1980. Indian Regional Navigation Satellite System, a state-of-the-art satellite-based navigation system developed by India is Indian Regional Navigation Satellite System. Apart from India, a radius of 1,500 kilometers, including the Indian Ocean, and countries like Pakistan and China come under its surveillance. Now onwards, it is Bhuvan. Bhuvan is a satellite-based geoportal platform developed by ISRO for the purpose of preparing maps of Indian territory by using its own satellites. Bhuvan made its humble beginning in March 2009. Basically, it is a remote sensing image portal. The prime function of Bhuvan is to prepare online maps by the maximum utilization of GIS and remote sensing technologies. Satellites belonging to IRS service are used for data collection. The map making facilities available with Bhuvan are more effective than that of the Google Earth and Wikimapia. One can prepare very precise maps since the spatial resolution of the photograph made available by Bhuvan is 10 meters. Let us have a glance at the service provided by Bhuvan. Following facilities can be availed by visiting the web portal. Bhuvan 2D, it provides 2D visualization of Indian terrain. Bhuvan 3D, it enables three-dimensional visualization of the features of Earth's surface, information related to climate and environment, disaster management service support services, ocean services, services related to agriculture. School Bhuvan. School Bhuvan is a map-based e-learning portal for the students which provides awareness on country's natural resources, environment and their role in sustainable development. It is an initiative of the ISRO with National Council of Educational Research and Training. Learners can avail this facility by clicking the icon School Bhuvan on Bhuvan web portal. My Map. Create a map. This is a mapping tool available at Bhuvan web portal for preparing maps of any region in India by obtaining the details of the surface features with the help of GIS technology. Flood control. In the contemporary history of Kerala, it has witnessed the most devastating moon flood in the year 2018. The intensity of flood faced by our state and the damages it caused are inexplicable. The possibility of satellite remote sensing has been utilized very effectively to overcome this natural disaster. We use this technology for the preparation of flood hazard maps of affected areas, estimation of loss due to flood, understanding the post-flood conditions of rivers, and the assessment of damages of the areas flooded. The details of the surface features collected through remote sensing can be analyzed with the help of GIS to prepare flood predicting models by identifying areas vulnerable to flood. GIS is one of the fastest developing technologies. The technology is being effectively applied in various fields like industry, education, agriculture planning, irrigation, forestry, transportation, disaster management, disease control, market analysis, tax collection, defense tourism, natural resource management, etc. This has now become one of the most useful technologies in trade communication, resource management, and planning and development in particular. The wide use of this technology give away by tremendous job opportunities in this field. Many world-class technologies institutions conduct various courses and training programs in geoinformatics which include GIS technology, remote sensing and so on. Candidates can get better job opportunity by taking part in such courses and training programs. Details of some institution in India conducted such courses. Indio Institute of Remote Sensing, Survey of India, IITs in India like IIT Kharagpur at Science, IIT Kanpur at Science. The world is fast leaping towards progress. The relentless quest for knowledge and the untiring efforts of man are the base of all the advancements. New discoveries and advancements in technology have made human life better. Hope you will get involved in these efforts to make use of the technological progress for the welfare of mankind. So that's all about this chapter. If you're interested, please do like, share, and subscribe my channel. Okay, thank you.